Okay, I'm going to introduce the cast rule, and that's for finding more than one angle with the same trig ratio. And we're going to constrain ourselves to be between 0 and 360 degrees. So there's actually an infinite number of angles that go along with every trig ratio, but we're constraining ourselves to a single full rotation. So we're going to find the two angles between 0 and 360 degrees. So we'll start off by answering this question here. If theta is 30 degrees, find another angle with the same sine, find another angle with the same cosine, and then find another angle with the same tan. So to start off, theta is 30 degrees, and we're going to find another angle with the same sine. So I'm going to draw 30 degrees here. Remember, that's 30 degrees counterclockwise from the positive end of the x-axis. Now this is from our special triangle. So we know that this is 1, this is root 3, and this is 2. So the sine of 30 degrees is equal to 1 over 2. I'm now going to look for a second angle. If this is theta, I'll call that theta 1. I'm now going to look for theta 2. And theta 2 has this property. The sine of theta 2 is also 1/2. But it's not going to be the same angle as this 30 degrees. What I do know about our second angle is it's going to have the same reference angle. That means that wherever it is, our second angle is going to be 30 degrees from the x-axis. So it may be over here, it may be down here, or it may be down here. If it's down here, the y value will be negative. So there's no way that theta 2 brings us down here. If it's up here, the y value will be positive. So if I have 30 degrees here, again, filling in the values for my special triangle, this is 1, this is root 3, and this is 2. The sine of 30 degrees is 1 over 2, and likewise the sine of this angle here, which is 180 minus 30 degrees. That makes it 150. So my answer, find another angle with the same sine as 30 degrees. My answer is that theta 2 is 150 degrees. To verify this, the sine of 150 degrees is the y value over the r value. And because we have 30, if that's a 1, that's a 2. So the sine of 150 degrees is 1 over 2, the same as the sine of 30 degrees. Okay, we'll now look at the second part of this. We're going to find another angle with the same cosine as 30 degrees. So theta 1 is equal to 30 degrees. I'm going to draw it again here. This is 1, this is 2, and this is root 3. The cosine of theta 1 is adjacent over hypotenuse, or the x value divided by the r value. It is root 3 divided by 2. I'm going to look for another angle whose cosine is also root 3 divided by 2. Notice root 3 has to be positive. Root 3 is along the x-axis. So my other angle must keep me somewhere over here where the x value is positive. If I rotate over here to an angle greater than 90 degrees and less than 270, everywhere here my x value is negative, so the cosine of any angle over here will be negative. So I must be over here. My reference angle again will be 30 degrees. So my actual angle, starting at the positive x-axis and rotating counterclockwise, will be 360 degrees minus 30 degrees, which is 330 degrees. So if theta 1 is 30 degrees, and we're looking for another angle with the same cosine, theta 2 is 330 degrees. You can verify this as the cosine of 330 degrees is equal to root 3 divided by 2. Now the third part of our question. Find another angle with the same tan as 30 degrees. So theta 1 is 30 degrees right here. This is 1, 2, and root 3. The tan of 30 degrees is 1 over root 3. It is the y value divided by the x value. Notice that that's positive. It's positive because we're taking a positive value and dividing by another positive value. If I rotate over here, my y value is positive, but my x value is negative. Remember, this is the positive direction of the x-axis, and this is the positive direction of the y value. So if I'm over here, y is still positive, but x is negative. A positive divided by a negative is a negative. So the tan of any angle over here will be negative. I'm not going to look here for an angle with the tan equal to positive 1 over root 3. Likewise down here. If I look over here, my y value is negative, my x value is also negative. So I shouldn't have said likewise. My answer is going to be over here. If you take your negative y value and divide it by your negative x value, you're going to get a positive number. Because that's 30 degrees, I'm going to have a reference angle of 30 degrees. I can then use my special triangle to fill in these values. This is going to be negative root 3. Now remember, it doesn't show up as a negative on your special triangle because it's only looking at lengths. But when we're on this axis, we use positives and negatives because the negatives indicate the direction. So that's root 3. That's negative root 3 going this way. And this is negative 1 going this way. Our angle, starting here and going counterclockwise, is 180 degrees plus 30 degrees, which is 210. So the tan of 210 is equal to negative 1 over negative root 3. The negatives cancel each other out, making the tan of 210 positive 1 over root 3, the same as the tan of 30. So to answer all these questions, find another angle with the same sine as 30 degrees. The other angle with the same sine as 30 degrees is 150 degrees. The other angle with the same cosine as 30 degrees, theta 2, is 330 degrees. And the other angle with the same tan as 30 degrees is 210 degrees.